Final lesson of this unit is using addition, subtraction, multiplication, and division with calculators to evaluate algebraic expressions. So to start off with, we're going to look at what an expression is. An expression is just a mathematical operation that involves letters and numbers. So in the expression 12 plus b, the letter b is a variable. A variable is a letter or symbol that represents an unknown value. So if I don't know a value, I can represent it with a letter, and then that will be my expression. When variables are used with other numbers, parentheses, or operations, they create an algebraic expression. So we have a variable, then we have an operation of addition and the number 2. Here we have multiplication, and here we have some multiplication, addition, and subtraction. In an algebraic expression, a coefficient is the number multiplied by the variable. And normally, in mathematics, we write that coefficient in front of the variable. So in this expression, in 6m, 6 is called the coefficient. In this one, we have two coefficients, 8 in front of the r and 7 in front of the m. And in this last one, we have a coefficient of 14 in front of the b. So a term is the name given to a number, a variable, or a number and variable combined by multiplication or division. So a term. We have algebraic expressions. A is a term. Then we have addition, so we're getting to another term. 2 is also a term. In the next algebraic expression, 3m is one term. Then the addition will start a second term. Then the subtraction will start a third term. So terms are separated by addition and subtraction. So everything that's multiplied or divided together is a term, and then they're separated by addition and subtraction. So you can see the list of terms right there. Then in algebraic expressions, we have a constant, and it's a number that cannot change its value. So if we look at this expression, 5x plus 7y minus 2, we have x and y. They are variables. We could change their value and do several problems and give them x and y a different value every time. But -2 is a constant. It will not change. So even if we change x and y's value, then the -2 at the end here will not change its value. It is a constant. It has no variable. So in these four, we're going to identify the terms, the coefficients, and the constants. So in this first one, we have the term 12a, 6b, and 4. So we have three terms. Separating the terms is subtraction and addition. There are two letters or variables, a and b. In front of a is a 12. In front of the b is a 6. There is subtract in front of that, so that's actually a -6 in front of that b. And that would be the coefficients. And then the constants in that first one is 4. Now in the second problem, we have 4x as one term, 2y as a term, separated by subtraction. And so we have coefficients of 4 and -2, and we have no constants in that one. In the third one here, we have one term, two terms. Now, C, you would think maybe you would say it does not have a coefficient. But any variable by itself is actually one of that letter. So this is 1C. So it has a coefficient of 1. And then we have a constant of negative 32. Again, the subtraction in front makes that a negative 32. All right, on the last one, we have two terms, 3x and 2. We have a one coefficient, which is 3. And we have one constant, which is 2. Now that slide is all messy. All right. Now, when we have this word here that says evaluate, and then we have our algebraic expression, and remember x and y can be different values, but in our problem we're assigning 4 to x and 2 to y. So the way we evaluate that is 2x is multiplication, 2 times x, and we would take the x and we turn it into a 4. Now, a common mistake that some students do is saying that that is 24, but it is not 24 when you replace x with a 4. That is incorrect. We don't want to have that. What we want to have is 2 times 4, because that's what 2x, that term, represents. Then there's a plus, and then we have our 5. And again, it's not going to be 52. It's going to be 5 times 2. Then we can put that in a calculator or use our order of operations. If you put it straight into the calculator, 2 times 4 plus 5 times 2. I think with the TI-83, you could put 2, parenthesis, 4, parenthesis. You can do it just like that. Or you could put in 2 times, I'm going to use a little bitty x or a dot, 4 plus 5 times 2. But either way that you put it in your calculator, you should come out with a result of 18. Here's another expression. This expression is 6a squared b. The variables are a and b, and a is going to be assigned a negative 2 and b a negative 1. So we're going to replace the a with a negative 2, and we're going to replace the b with a negative 1. It's going to be very important when you're dealing with exponents that you put the number, when it's negative, it has to be put in parentheses to get the correct answer out of a calculator. The calculator does not know that you want to square negative 2 if you do not put it the whole negative 2 inside of a parenthesis. So you want to make sure that you do that. And so you may want to put every number you have with the exponent in a parenthesis so you don't forget, but you have to do it with the negatives. So this is going to be 6. You can put this straight in your calculator using parentheses, but this is 6 times 4 times negative 1, because negative 2 squared means negative 2 times negative 2, which is positive 4. Multiply all those together, and the result is negative 24. Here's another expression, and it tells you what to use. And so what we're going to do is take the z. Let's start that again. We're going to change that z into a 2. Minus 1 minus parenthesis 1 minus, and we're going to change that y into a 1. So we are changing the z into a 2, and we're changing the y into a 1. Then we have 2 take away 1 minus parentheses 1 minus 1 parenthesis. Now you can put that straight into the calculator or use order of operations, and either way you're going to end up with 1 for a final answer. Alright, in the next example we have y plus x minus y divided by 5. X is 7 and y is negative 5. So we're going to place all y's with negative 5 and all x's with a 7. So this first y is going to be a negative 5 plus the x we're going to change to a 7 minus, we're going to change the next y to a negative 5 divided by 5. Now this is where some problems come in with some algebra students. The subtract is right there. The negative 5 is here. So you have subtracting a negative. Now you can just put this expression here straight into your calculator, and when you do so, you'll get your final answer. Double check your calculations and that kind of thing. Or I can, clean it up a little bit or use some order of operations if I want to as well. Know that subtracting a negative is the same thing as adding. So if you're taking away a negative, that is actually the same thing as negative 5 plus 7 plus 5 divided by 5. But you can go ahead and just do subtracting the negative all into your calculator, and it will do your order of operations for you, most likely. Make sure you have a calculator that does that. And so when we do this problem, you're going to end up with 3 for a final answer. If you put that into your calculator, that's what you'll end up with for a final answer of that problem. Now the last example, we have this algebraic expression. X is negative 6, z is 3. So we're going to change the x into negative 6. But again, we have the subtract, and we have the negative 6. Plus, we have a z that we're going to change into a 3, and that's going to be cubed. Again, this right here, subtracting a negative, is actually can be changed to addition, the whole thing. If I want to rewrite it, I could rewrite it, because that's what subtracting a negative is. It's actually addition, because you're going to change the sign if you wanted to. Some of you are taught to change subtractions to adding the opposite. So if you add the opposite of negative 6, you're just adding 6. But sometimes you were taught that by a math teacher along the way, most likely. So we're going to put this in the calculator. And you should come up with 23. Alright, so that concludes our lesson on algebraic expressions and evaluating them. Thank you for listening.